monitor, control, and maybe of the environment. Just to say that these numbers, this data belongs to something that we can see, and in some way we can touch interactively with it. The main features of this case study that can be applied also to the different ones I will present later is that we wanted to create a representation that is data-driven, so that everything that is represented there comes from a sensor, and we have a bidirectional interaction within these two worlds. We can communicate from the real world to the virtual one, and seeing reflected this the change of status, but also on the opposite side. Sì, però los vídeos están todos ahí dentro de la sí, porque son el marco directo. Y además creo que no es la versión All right, it seems that it's not working well. creo que hasta que no estoy dando demasiado y puedo hacerlo así, sí, Okay, I will try to make this way because I think it's faster. All right, this is simply to present our architecture of the digital twin. We have of course the physical world. We start with that, and we are mirroring in virtual representation, and there in between there's which is in charge of connecting the different sensors and devices to get the data, to store this data, and to provide the visualization features. And then on the top of this platform, we can build different kind of services using protocols, internet protocols, network interfaces, and so on. And the ones that we are going to talk specifically is about the different virtual interfaces. Of course, I will stress the concept about virtual reality, but we can apply almost the same concepts also to augmented, mixed reality, and so on. So every kind of extended realities, digital realities, we can be included over. Yes, the device, the way you can interact with them, and so on. Also, well, there are also some concerns about the graphical capacity of the devices, and so on. So it depends. You need to choose a trade-off between the different parts. All right. I will try to show you a video over there, if okay, to show some ideas of our digital twin. This is our section, a part of our installations over there at Sedint with these corresponding digital parts. So it's we try to have as much more realism as possible, so to improve this part of context awareness without charging too much with details that can slowing down the applications. So with the different devices. Okay, this is an interface. We can interact in several ways. We can change the scenario. We can change the environmental settings in terms of weather conditions, in terms of days, hour of the days. We can connect with the APIs to get the exact weather conditions over there, so we can simulate with as I said before, data-driven simulation, and experiment with other conditions. Okay, well, English. Okay, we have both English and Spanish, and then we can show also some different charts, graphics, interactive, of course, to get an idea of what's going on, what's happening over there. There's an interaction with the different sensors and devices. In this case, it's an environmental device where we can, in the analysis part, we can load other graphics and see, for instance, the typical, in this case, weekly pattern. So it helps us to retrieve the relevant information, put into the context, and see what's happening. I mean, we can detect that there are some anomalies, there are something going wrong, there are some relevant patterns, and so on. We can move across the city, across the environment using teletransportation. This is another example. We get different devices to showcase, and here there's a small part where it seems that the devices has not been connected, and actually is not giving us any data. So it's something that an analyst can see and detect why it happened. As I said before, we can interact with the reality, so we can switch on luminaire street light from the virtual environment to the real one, which helps for remote controlling and managing and monitoring that everything is. I will skip some other part and try. Let's open not broken nothing over there. And the interfaces, of course, they are uploading reflecting the new information. And also in terms of connectivity, we can interact with gateways, in this case, serving different devices, and see if every device that should be connected to it is working, or at least is responding and is sending some information. And okay, and I think that as you can see, there are some arcs over there. Sorry, some arcs over there going through the different locations of where are put the devices. And okay, there are also parking and so on. For instance, here, where you can see in this case the corresponding chart of occupancy. There should be there. All right, so the different possibilities. In terms of challenges, of course, I will just an overview. We have connectivity challenges because we need to take into account the different protocols, so which works differently. I have different data structures and so on, and also the frequency of their uploading information. So this should be considered into creating both the digital twin and the interfaces. And as I said before, we need also to find a trade-off between the graphical realism of the application to provide the sense of immersion to the user, but also to take into account the computational resources of the devices, of the virtual reality devices we are using. There are the use of different technologies and the protocols can introduce some sorts of challenges in terms of integration, maintenance, and so on. So we needed to take into account that this part can be tricky to be managed, and we needed also some kind of let's say proper protocols to manage everything. And there's a lack. Usually, as far as I know, there's a lack of digital twin authoring tools. So that could be a little bit difficult to create digital tools in a more efficient way. So that could be an interesting point for to be treated in the future of digital tools. We'll skip this part just because I think we are running out of time. All right. So we are just to provide an overview similar to this one, at least in the terms of the overall scenario. We are focusing more on the part of street lights controlling, just not to retrieve the status of the luminaires, if they are switched on, off, or if they are working or not, but also to provide some kind of a first person analysis of presence, of security, to test different combinations of illuminations, both in terms of locations, both in terms of dimming, level dimming, to get a sense of user presence, user capability of detecting if it feels safe, if it's still if I can see if it's enough for working and so on, or for any other activities that can be performed. In this sense, we need to integrate data coming from specialized softwares, like in this Relux and so on, we provide the features, all the interesting features to simulate these scenarios, but they are specific for this sector of this segment of the specialists, and usually they don't use a non-interactive or first-person simulation view. So that's why we needed to, or we wanted to add this kind of a feature, especially where we can test the different configurations in a more efficient and rapid way. Through the interaction and so our proposal in this research was to connect these two realm by computing a part of this of the data we need from there and importing directly into the simulation to create to reproduce exactly the environment that we wanted to reproduce. For instance, by applying the textures to the light components or providing some effects in lighting effects both at runtime or in a static manner. So our solution is a combination of these two words, and you can see some results over there. In this case, we are showing the facilities at a campus in Toulouse, the Université of Toulouse, and we created these interfaces to simulate different illumination scenarios. With a fisheye camera that can help experts to compare the different the real images taken from cameras with the ones simulated over there. There are a menu to change the different settings, for instance, to show the gradient, to show just how the graphical engine is reproducing the lighting effects, and then adding this new layer of data coming from a more specialized software. You can freely work over there to get the different points of view, and there are different scenarios. This one of the street lights at a different position and different dimming level. So you can compare and have a look of what could happen in reality when this configuration will be finally applied. All right. And then last but not least, there are also some, we have also some digital twin for urban mobility safety, in particular in collaboration with other UPM centers like INSEA. And the idea is to help to detect how vulnerable road users behave in streets, especially when in a risky, let me say, risky or hazardous situations, and how the furnitures of the city, the urban furnitures of the city, can hinder their vision in when crossing a street or whatever else. So the idea is to get to model these behaviors, and using a virtual environment to get the data about how they are behaving. In this case, there are not good data about real behaviors of users, so we need to use virtual reality to simulate them, and it's particularly difficult because people have no linear behaviors, and they can change their mind. They can while walking, and it's harder to predict exactly how they can behave under particular conditions, like, for instance, the cognition workload, the personal conditions that they have, they experience in the moment, or depending on the age. Of course, it's not the same thing that an elder is crossing the street than a young people. And then, we are a part of that. We are assessing users' sidelines, depending on the position and depending on the different obstacles in the street. So we can see. All right, that's just to show some of the. This is the longest, the longest one, but I will. just to have some. All right, this is a scenario we are reconstructed. This is the ground ubicated in Grandia. All right. There's an interface where you can switch from the HMD vision to this one, where we can test the location of different elements, and then see positioning over there reflected in the environment. And then if I will try to this vision cone of vision, where you can see the different obstacles, both static and dynamic, like other pedestrians or cars, and how they can affect the visual under different positions. Of course, this part is just for an analyst. That people are using the VR devices are not seeing this cone. It's just for analyzing and getting the data from there. So the idea is to study a little bit how the different, the relative locations of these parts can affect the behavior of people, and provide guidelines to construct or to arrange differently or better these different urban furnitures. We have also built an editor of scenarios where we can construct module by module the different layouts of the street we wanted to reproduce. And well, I think that you get an idea of what we are doing over there. All right, just to skip to the conclusions. I hope to have, besides the technical problems we experienced, I hope to have provided you an idea of that the virtual reality can be really, really useful as an interface for digital twins. Of course, not everything can be used. Not every digital twin can be used in virtual reality. It depends on the context and so on. But in general, if there's this opportunity, for instance, in terms of urban planning, or in terms of general simulations. So the virtual reality it's a really useful technology to expand the understanding of a single environment, and can be used across a variety of fields. Actually, it can be used also as a communication tool to gather different stakeholders coming from different domains, and putting them together to agree on what they are seeing, and finding better solutions using these simulations. Of course, digital twins and then virtual reality, if they are on the top of them, need a robust infrastructures over there. So we need to take into account this part to get the most of the two worlds working together. And of course, there's a need to search for different trade-offs depending on the objectives of your simulations, of what you wanted to visualize in terms of resources, time, graphical rendering, and so on. And about the future, well, this is an open discussion. We don't use, for instance, actually we don't use BIM tools. And one thing that we wanted to introduce is this interaction within the BIM tools and the softwares and virtual reality engines. But it applies also to several other tools, paradigms, standards, and so on. So we need to take into account these parts when we are building digital twins, but also when integrated with different technologies. Because right now, to take advantage of this paradigm, you can also include artificial intelligence tools, or 5G, or cybersecurity cybersecurity features, and so on. So we need to take into account that we are not working on something closed, but we hope we can open up different possibilities to other technologies. And for me, it's everything right now. Okay, there's some references of our works, and thank you very much for your attention. And I hope you will enjoy the rest of the day and try some virtual reality applications to enjoy that. Thank you very much.
Okay, I'll start. Okay, for some technical problems, we are going to interchange the two speeches that were previously scheduled, and now it's a pleasure for me to introduce you to Aitor Aragon, who is a civil engineer, passionate with this idea of bridging digital and digitization and sustainable engineering with the construction field. Very, very difficult task. Aitor is now have it here because he has a lot of responsibilities with the European Commission and with the European Normalization Center as is part of the Spanish committee, and he's now secretary of the operational energy performance assessment of buildings and the digitalization of construction products performance characteristics. In those committees, he's the secretary, but the one that I think is more related with us here is that he is the secretary of the working group 9 in the European Committee of Normalization, which is for digital twins in the built environment. So he's very aware of all the things that are happening in this field. He's closely related with all the, not only European, but a global network of people working in this field. And he is also preparing for the European Commission the system for working in a study for preparing the system for the digital passport. So I think he's here with a very interesting speech, and you should take advantage of having him here. This is a real pleasure. And additionally, we are very happy because he is also now starting his research and he's working with us at the school with his PhD. So Aitor, thank you for coming, and I pass you the floor, and thank you again for coming.
Thanks a lot, Marcos. Thanks a lot for the opportunity for me here. I will be quick. I'm a terrible presenter, so I have a lot of slides, but the idea is that if some of them are interesting for you, you can check them later. So I would try to tackle two main things, which is complicated with the time we have. So I will be quick. Sorry for my English, and I speak even faster in Spanish, so it's hope everything is clear. I work for the Spanish standardization body. You have one in your country. You have BSI in UK, SAC in China, or DIN in Germany. Well, we're in Spain. I work in the Spanish one. We are a non-profit association. We are private, and we are, let's say, an association of associations. The cement industry, steel industry, car industry, they are our members. And we work developing standards, as Marcos just said. I work in the construction unit of UNE, working mainly in two fields: sustainability assessment and digitalization. I'm the secretary of the Digital Twins Working Group. These are my two fields. A few years ago, I was more focused on sustainability. I was in charge, for example, of the Spanish EPD program outside the standardization, or working also there at the European level. But what I felt is that all this data that we have in the environmental field, which is very costly for companies, are useless because we deliver the data in PDF. So when you are at building level, what do you do with that? It's impossible to deal with that. So we are working on trying to solve this from the standardization field. What is a standard? A standard is a document, but not just any kind of document, a lot of standards. I think that it has two main characteristics. It's developed by consensus. 51% is not enough to approve it. And all countries, for example, in Europe has to vote. What's that? And it's approved by a recognized body. In Spain, we have one, which is UNE, but for example, in Germany, you have two, one for the electric sector and one for the non-electric sector. The European Committee for Standardization is the non-electric part in Europe. We are not only the EU members, we are only EFTA members, and also other like Turkey, UK, or Switzerland. And we develop standards at European level. One thing that I think is very important in Europe, we have something we call the single market, and the single market is based in the principle that we have the same rules here. So when a standard is published in Europe, for example, a standard for digital twins, it becomes a standard in all the countries. You cannot avoid it. It's mandatory to adopt it with no technical changes. And if you have any standard that is divergent, you have to cancel it. So that is a way to make the market, the single market works. How this works in the digital twins environment, this is a simplified idea, but we have a committee, European committee, which has relations with a lot of things. This is simplified because the reality is a little bit more complex. And I was working on this, I have to complete it, but just to have an idea, we have the BIM committee in Europe and in ISO, which is international. We have the Digital Road Passport European Committee. We have DIS, we have ITS. We also have few things about digital twins, more focus on manufacturing at the ISO level, step, format, the commission. We have a lot of things working around building smart. The BDTA, Building the Digital Twins Association. I will have to complete this soon. But the idea is that it's a complex environment and we are trying to work with it. In Europe, we have this working group. This is a little bit old. I will update it now. This is the structure we have in Europe. We have the digital twins, but it is based on other things. How we exchange information. We will have to define competence in digital twins, terminology, things like that. This is how we work in Europe. It has been updated. We created two new working groups for BIM objects to simplify, and another one I'm the secretary now is the digital format for, let's call it a DPP. We will go into that at the end. The technical committee meeting is now. It's Saturday at 9. That's why I will not be able to attend all the meeting, but a lot of things are happening. What happened in digital twins? Well, we were contacted by the BDTA, Building Digital Twin Association. They were working on a project called Sphere, and they wanted to create a standardization group to develop European standards for digital twins. We made an assessment, and we considered it was better to have it in Europe, because then you are sure that all European countries have the same standard. That didn't happen in ISO. If ISO publishes a standard, we can decide to adopt it or not. This work was approved, and we started working on April with the drafts. The kickoff meeting took place more than 2 years ago, and we have a lot. I'm not sure what these black things are, but well, a lot of meetings took place. We started defining what we want to do. We wanted to have a standard for definitions, concepts, and framework. But it was we get a lot of reactions. People thought at the beginning that we first need to assess what is the state of the art, what is happening in digital twins in Europe. So we did that. We started a technical report, and we approved it, and we start gathering that information in this report. What we did is we prepared a template, and we sent it to all the mirror committees, to research projects, and things like that. We received 37 use cases that were considered complete. If it were not complete, they were not even considered. And we only rejected 3 of them. Many of them, we had an iterative process with the people that send them, because we did not understand what they mean, or we proposed several changes. And at the end, what we did is we published that use cases, and we prepared like a structure. We try to see if we can find common typologies or things like that. And with that, we published a technical report. You can see it in this screen, perhaps online. But here you have the template that we used at that time. It's published. It was 2024, so it's available for all of you. In principle, it's published in English, German, and French, as all European documents. And in some cases, you might have it in your native language if it is not one of them. this is an example that I think you can read. I presented because I was in this research project. We have several of these. Is a project assessing how to use BIM and digital twins for energy performance optimization. So we presented, for example, this use case, and it was included in the document. I did not participate in the assessment, so even if it was my proposal, I mean, I think it was it can be presented. So we had these use cases, and we then decided to move to the next step, which is concepts and definitions. This April we started the project. It was approved, and we start working a little bit before, and now we are working on that. We are working on the drafting. We had what we consider a mature draft in July, and we sent it. We have a stage for comments. We received comments. It closed in September, and now we are working in dealing with comments. We did not receive any major thing, so we think we should be ready to send for inquiry, which is probably the most important part. It's a ballot that take 3 months, and all countries has to reply probably before the end of the year. That is our expectation. So we might have a standard defining what a digital twin is, more or less, from a high level perspective. Oops. Well, I will keep reading and hopefully. Okay, that's better probably. We hope to have it in 2025. What does this might mean for you? When you have a standard, if you, I guess in your countries, standards are used, for example, for public procurement, for private procurement. People today, they ask for a digital twin in a tender, but what it is? Probably if you present a BIM model 10 years ago, maybe 10, 15 years ago, they will accept it because they don't want what they are procuring. So if we can narrow what we mean by BIM model, what we mean by digital twin, we can help procurers, or we can help people understand what we mean. It's not easy because we don't mean the same, at least in our group. Probably we make here a debate, but let's agree that we might find a definition, even if you are not 100% agree with it. We are also working. The idea is also to use it in other committees. For example, I'm the secretary of a working group. We are developing a methodology to assess energy performance in buildings. Now we use the building as it is, but the idea is to use IoT data and BIM model or digital twin, so you can have like a yearly updated certificate. That will take some years, but it will probably be based in this document. This is digital twins, but I'm working on a thing that if you are working in digitalization, it might be relevant for you. I will try to go faster as they ask, but sorry for this, probably it's not your field, but in Europe, we have something we call the CMR. It's very important for construction products. It's how we communicate product data between the manufacturer, the designer, the construction company. This document is under review. It might be published. I didn't check this morning, but perhaps today or next week, very, very soon. This November, we'll have a new CPR. What happens today and will remain the same in the next DOP is that the manufacturer is allowed to put all this information on their website. What is happening? That they are using a PDF. So again, from my perspective, useless from a digitalization perspective. So industry and some people, we started working on this like in 2015, 2016 is the first white paper. We started working on an XML at that time on to communicate this performance information so you can read it from your model. The project was stopped at Europe. It didn't move forward. So we decided to continue in Spain. We improve, I think, the document we have, and we start making pilots. We have this structure for cement, for structural steel, aggregates, natural stone. We will try to work on that. Here you have some references. But why I'm telling you this, because Spain probably is not so relevant for many of you. Because based on this experience and others, we have proposed the creation of a new working group. And our idea is to have a common digital format for all construction products in Europe. This is important and linked with the CPR because the CPR includes a concept that is called digital product passport. It will contain this information and other But what we want is that it is structured in a way that it can be used in BIM, in your digital twin, or in any other thing. It's a field in which, if you are interested, now is the time. We started just 2 weeks ago, so you are welcome to participate. The kickoff meeting took place in Brussels. Here you have the face-to-face attendance. We have like much more online, as you can imagine. And well, I will not go into this, but this is aligned with other regulations in Europe, with battery regulation, the ESPR that covers, for example, lighting or many other things. So this is something that that affects everything that is installed in a building and many other things. This is something that will have to be developed. It's not yet decided. The Commission will have delegated acts. It's not important what it is, but they will define next year how they will implement this and how they will make it interoperable with BIM. And to do that, they launch a tender for a feasibility study, how to implement the digital product passport in Europe. And we presented a consortium of 3 companies, 2 of them Spanish and the other one from Norway. And well, this is what we are doing. I will go fast, but it might be interesting for some of you because this can interact with the digital twin. We had 5 options for how to manage the system, and we have reduced them to 3. The first option is that the Commission will have all construction product data in one single place. Hopefully you will have an API, but developed by the Commission, and you will have to interact with it. Option 2, which will also happen in the eco-design regulation and probably battery regulation, is that you will have service providers. Oh, sorry, I didn't translate the title. You will have authorized service providers, what we call a federated system. And these service providers will host data, but they will have to have a backup, probably another service provider, because the persistence of data, we will not go into detail, but it's one of the most important things or requirements for the CPR. And the last option is that the manufacturers will have all the information in their website. This is a challenge because for SMEs, it's quite complicated to have a compatible system, and they will be required to have a backup. Why? Because the manufacturer might disappear, they might have a cyber attack, or it's impossible, or we consider it's not feasible to prepare a search system that can search and scan all manufacturers in Europe or all the organizations that are sending products to Europe. So it's easier to make search and index the backup system because it will be a limited number of places. Why I'm telling you this? Because if you are interested, I'm not sure. We launched a survey on how to develop this. What is if you work on industry, how do you think this should work? You will have in the presentation the link. You have the QR, the deadline. You have what day is it today? Probably 2 weeks. And it's intended for those who generate DPPs today, those who put the CE mark into their product, and those who use it. Probably you will be in the second category. If you want to use a DPP, what do you think it should have? We have a presentation for this survey and everything. The 20th of October in DG Growth is like the Ministry of Industry in Europe, and the presentation, if anyone is interested, we can share it with you because they are public. And as a summary, sorry, probably too many things. We are working in the code is it's 442. Sorry, I finished it yesterday and I was tired. We have a working group for digital twins in Europe. You can participate through your standardization body if you're European. We have other working group that is trying to digitalize all the information of construction products that can be used in a digital model. And I didn't have time to go into that, but I think it's obvious that having this information in the DPP can be integrated in, for example, in a building digital logbook that might be close to a digital twin, depending on the level or the specifications. And you can update all this information with, for example, the maintenance you make to elevator and things like that. I think that the interconnection with this between products and assets is something that to be explored and that might be relevant. That's all. I'm not sure if I fulfill the deadline. You have my email, or you can contact through the university or Marcos or or if you have any question. I'm not sure if we make questions or if anyone. Probably too fast. Sorry. Thanks.
So hello, good morning to everyone. This is Nacho González Tejada. I'm the director of the Center of Excellence on Digital Twins for Infrastructures and Cities that we are establishing. So this master program is possible because thanks to the Digital Europe program, who is co-funding this initiative. And we have two main goals. One is to develop this master program. And the second main goal is to build that ecosystem around. To build that ecosystem, we want to establish a center that will be joint international, together with our Istanbul Technical University, Budapest Technical University, École de Pont-et-Chaussée, and UPM. So working on the bylaws of this center that will have three main missions. One is to provide education and training. This includes this master program, but in the future we will include other short and expert courses and tailored education. The second mission is to generate and transfer technology. And the third mission is to foster entrepreneurship and business ideas. But this is the vision. We have the visions, and I will borrow the words of Robert Schuman when creating the European Union. The challenge is huge. So this will not be made at once. We will achieve this after a series of concrete achievements. So our purpose is not to work too much on the regulation, but to work on the achievement. So by the time that you will get the title of the master program, if you hard work, this center will be established. And we will, and we hope to have some success stories. And of course, we expect that you will bring your ideas. Because as we are talking about the build sector, maybe we can think on this like if we are building a bridge, trying to bridge the gap between the build sector and the digital sector. And that bridge, it's maybe a hanging bridge, let's say, it's more beautiful. And it will have two main towers. And those two main towers, one would be academia, but the second will be industry. In industry, as you will be alumni, and as you are now learners, you can probably, you are coming from industry, so you are a part of the main tower, but so we need you. And because this tower is really important for our approach, the links with industry. You know that industry is participating in the training. It's participating with the capstones, some professors, some lectures coming from industry, but also in the project as we want to achieve in these three missions of education, entrepreneurship, and technology generation and transfer, we want to have industry. And one of these examples is our next outstanding speaker. He is Roberto Fernández Ergueta. He is coming from NTT Data, which is a multinational IT services and consulting firm. He's a mathematician. He's advisor in the field of digital transformation and strategy. He brings more than 20 years experiences mixing technology, high technology, and business. His main areas of expertise is strategic planning, business transformation, innovation, IT strategy, and emerging technologies. I have heard that he is an excellent speaker that is giving lectures everywhere worldwide. And I don't know where are you working, but probably now the business related to civil engineering, we have like three stages. Maybe you need to develop the digital part. Maybe you need a transformation, or maybe you need a revolution. It doesn't matter the level that you need, but in any of these three cases, I will ask Roberto. Okay.
Thank you so much.
Hi all, thank you for introducing me. I'm delighted to have the opportunity to share with you our vision related to digital twins. The title of the deck is related from Gaudí, because Gaudí is a source of inspiration for architects, artists, and I think from everybody that is related to innovation. So I will use this metaphor to explain our vision of the digital twins, oracles, because we are focusing on real time. And of course, we need to talk about artificial intelligence. That is one of the emerging technologies that is very that is pushing a lot in the digital twin field. So why Gaudí? We use the metaphor of Gaudí as father of digital twins because I don't know if you have the opportunity to dive deeper in the biography of this best-in-class architect. He's the father of the modernism, and he used to work in a workshop, in a room workshop with a lot of multidisciplinary guys, writers, drafters. So they work together trying to provide a multidisciplinary vision. So he don't use to make the common and simple plan, a blueprint. He prepared a building model, a physical building model. So he envisioned the concept of digital twin in the 19th century, because he was born in 1852 in a very complex socio-economic situation. But he tried to defy the traditional architectural conventions. He tried to make a transformation, to rethink the process, not to use the common techniques that the rest of architects have. So they try to reinvent, and even they create new materials, new technologies for his buildings. As you know, that they are considered by UNESCO World Heritage Sites, and even we can use the Sagrada Familia as metaphor because it's even under construction. And right now, the digital twins is even under construction with the power of the emerging technologies. So that's the reason that we use this metaphor related or linked to Gaudí, because he has a very powerful capabilities and he envisioned mentally the different buildings that he was to create. So as I mentioned before, he was the pioneer of this concept of 3D models with the physical building model that they work with the multidisciplinary team. And he put on the table a lot of new techniques and new materials to create the well-known buildings. So what is our vision? As I mentioned before, we need to dive deeper in the understanding of digital twin, because if I ask you, each of us has a concept related to digital twin. In our understanding of digital twin is, as you know, a virtual representation object, assets, even a city or even a territory. But what makes the difference is the possibility to combine the real time, the context of the real time with the simulation on top of this real time context. Because as you know, we have data, we can make simulations with a lot of historical data. But what makes the difference is to combine real time context and simulations on top of this real time. So this is the vision that we are pushing in the industry related to digital twin. And as you know, there are some entities such as Digital Twin Consortium that define the digital twin in that way. On the other hand, the digital twin is a key element to take advantage of the different emerging technologies. Even the concept of digital twin is not a technological concept. It's an aggregator of different emerging technologies. So if we can see this concept of Sagrada Familia as the Sagrada Familia of the digital twin, we identify different emerging technologies. We have the infrastructure, we have the IoT layer, we have the chance to capture data in different ways from different sources. Then we have to define the semantic model, the ontology to create the digital replication. And on top of it, we have simulation, real-time algorithms based on different mathematical models in order to visualize, to create a visualization layer to provide this value to different users. So this is the concept of digital twin. So the digital twin is not a technological concept, it's the aggregation of different emerging technologies. But what makes the difference is that we have right now the momentum, because the level of maturity of these emerging technologies provide us a lot of possibilities. Then we are going to have the opportunity to share with you some real projects to provide you what the market is doing in this field. But what I want to highlight in this point is that we are moving from static information sources like BIM, CAD, and we are incorporating this real-time information that provide a lot of value. So beyond the concept of digital twin, this is the different types of digital twin. The industry is working right now more on the predictive. We are combining real time and we are starting to simulate and combine with this real time. The aspirational digital twin is more related with live digital twin, that the digital twin should have capacity to act in an autonomous way directly to the physical asset. But right now, most of the projects are more related to predictive digital twin. But what we are seeing in the market right now is the concept of convergence, IT, OT, and of course, ET convergence. As you know, IT, the classical information technology system, the ERP, the CRM, etc. But right now we are combining with the OT, operational technologies that provides us value from controlling and monitoring factories and other information. So we are working very hard to combine OT and IT, but what makes the difference also is the ET, engineering technologies. We are living a second revolution in the geospatial data. We are not talking only about BIM, CAD, we have tram points, we have orthophotos, we have 3D models. So we have a lot of new data that companies and organizations are starting to face this challenge, and they need to identify the best way to combine this kind of data from different technologies. Because in the past, in the organizations, this kind of technologies works as a silos, fragmented information. There were engineers or urban guys that work with engineering technologies. There were the guys from the shop floor of the factories that work with the OT, and there were the guys from corporate area that work with the IT. So right now, they are starting to combine all this data. So this is a very important thing, and the digital twin is the key to leverage this kind of data, okay? So this is at Herranz, a reference architecture related to this convergence. As you can see, we have the logic related to how to acquire and collect data from different sources. This is a challenge, and a challenge related to standards. As you know, there are a lot of providers, sensors, devices, a lot of industrial protocols. But right now, in the past, in the industrial environment, above all in the industry 4.0, there was a standard called ISA 95, but he's moving because the ISA 95 provides fragmentation in the different layers. But right now, there is a concept that is called unified namespace, that is a way to centralize this data and to provide a standardization to collect data from different protocols, sensors, devices, and help us a lot to provide this OT layer to the different layers. So let me share with you some trending topic in the digital tool arena. As I mentioned before, one of the key approach is the concept of no platform approach. What is happening in a lot of organizations is that they have created digital twin as a silo in a business area. So they have a lot of digital twins, and right now they need to create the concept of digital twin ecosystem or digital twin of digital twins. So they're trying to avoid some vendor locking. So they start some concept of no platform approach that is based on open source. They're combining a common catalog of components in order to create this open, modular, composable, and scalable approach. So this is at Herranz, some key elements of this kind of architectures. As I mentioned before, related to how to normalize and acquire data in the IoT domain. This is a new concept, unified namespace. As you can see in at the top of the stream, in the past, there was like a spaghetti architecture point-to-point integration. So this is very complex to scale it up. So right now we are working in this concept of unified namespace. Even the vice president of Microsoft has highlighted in the past summer that Microsoft should be pushing to this concept of unified namespace. So they are rethinking the usual suspects tool from Microsoft in the IoT domain. So this is a very interesting thing. The other thing that is very interesting in the digital twin domain is that we are living a second revolution in the geospatial data. In the past, to create a 3D model of whatever, it was really, really expensive because you have to use video games technologies, but in the last times, we are living a commoditization of this kind of things. As you know, we have LiDAR scanners, but even there are technologies based on smartphones or even a simple GoPro that allows us to provide route points with a very high quality and density, and it is very amazing because it allows you to create this 3D model to, on top of it, could launch artificial intelligence algorithms or whatever. So you have to take in advance that in the open source community, there are a lot of, I don't know, right now, there are a lot of innovation, and even to reach map, there are open source solutions like Open Maps and other well-known such as Cision. So we are living a democratization or commoditization in this kind of things. As I mentioned before, this is the different LiDAR scanners to capture drop points and to capture this data, but what makes the difference is that this terrestrial LiDAR acquisition can be complemented with other information and even to apply AI for different purposes, automatic inventories, automatic layouts, remote study, and so on. So let me show a video that related to a real use cases that was implemented by Madrid City Council. This is related to the M30 and the possibility to launch on top of route points of the M30 and algorithms that allows you to identify in the M30 potholes, tree runs, the inclinations of the lanes or whatever. So one of the trends also is to create a geospatial master data. In the organization, geospatial data in the past belongs to the urban guys, to the engineers, but right now it's an asset that could be reusable for any department of a city council or an organization. So as you can see, this kind of technology that combines route plans plus artificial intelligence allows us a lot of information that could be very useful for use cases related to predictive maintenance and so on. Okay. So another, sorry, there is a delay between my screen and the big screen. Another trend that is appearing is this concept of geospatial data management and how we combine GIS plus BIM plus this kind of new concept like orthophotos, new route points, different formats of these route points, etc. Okay. The other thing that is very, very trendy is how we are incorporating artificial intelligence to provide value to this ET, OT, and AT convergence. We are not talking about descriptive analytics. We are combining with predictive analytics and even the concept of AI, taking into account not only GenAI, that we are going to talk a little bit about it, but also how to create a concept of autonomous agents in terms that we could create an autonomous software based on IA to take advantage of the interpretation of the simulation in a digital twin domain. So if, for instance, this is an assistant based on GenAI, we have our digital twin and we will interact with this GenAI. As you know, the large language model have some problems in terms of memory or context, so we are enable a specific architecture to provide extra value to this GenAI that is called RAG architecture, and it's very, very interesting as well in order to combine this kind of data. So in terms of use case, as you know, the concept of digital twin is a very transversal one. So there are a lot of use cases in the different sectors. The main cases are focused on these four domains: predictive maintenance, how to make operational optimization, real-time monitoring and optimization, and to enhance decision support based on real evidence. So let me show some real projects. This is a sample related to public safety. So you could scan an area with these E57 trout points. That is a specific kind of trout points that provide you a photosphere. So you could even incorporate different inventory of assets in this photosphere. So you can define a space and you can simulate a fire, and even you could simulate the best way to avoid this kind of things. So this is a sample. This is, as you can see, the layout, the visualization layer depends on the real needs of the users. This is an auto factory, so you can see the chain, the different devices, the different robots, and you can simulate in order to identify if there will be a problem related to stock or whatever. Sorry, I'm going very quick because we have only a few. This is a very interesting way, a very interesting sample, because we are combining OT, IT, and even ET. This is a factory in the north of Spain that was scanned by a LiDAR scan in the format E57 that provides you the possibility to create this photosphere. So it allows you to create an avatar. Some problems with. And what makes the difference is not to create a metaverse and an avatar walking around the factory. What makes the difference is the possibility to connect with this engineering environment with the telemetry and information in real time provided by the asset management. So what makes the difference is that you are combining a very photorealistic environment that it could be used for workers, but also to have what is happening in real time in the factory. So that's the difference of this kind of things. We are working a lot in the domain of cities because the concept of urban digital twin is a trending topic in cities as well, because they have invested a lot in the smart city, but right now they have the opportunity to take advantage of all this data and combine with other data that city can still have. So there are a lot of use cases related to cities, from urban planning, mobility, digital heritage, public safety, and what a lot of cities are doing. In the past, they have a specific digital twin for each boss, and right now they are trying to build this concept of umbrella, this concept of digital twin ecosystem in order to provide a unique point of access to this information and combine and aggregate a lot of information. They are trying to break in with the silos and with the black box that they have with some providers that are providing the service of lightning ways, because they are trying to recover the data and the concept of sovereign data in order to handle and manage their own data. And there are a lot of opportunities and potential using this kind of things. This is another sample related to a critical infrastructure. This is the byline, Puente de Bailén bridge here in Madrid. So with E57 trout points, we are recovering information from intensity, vibration, and other sensors in the bridge. And we are combining with some weather information in order to create some simulation related to the structural situation of the bridge. So as you can see in the left menu, you have access to engineering tools, but what makes the difference is to provide this vision that provides you value of what is happening in terms of simulation, what are the areas of the bridge that will suffer, taking into account this simulation. So this is another use case that the Madrid City Council has done and is working very close with Luca and their team in the IoT Mad Lab as well. another sample. Let me. This is this is the same sample related to critical infrastructure. So you have the opportunity to combine IT information with sensors that this kind of buildings have in order to provide telemetry in real time for this kind of things. Let me share. We have been working with the city of Cordoba. We have created a downtown, the digital twin of the downtown of Cordoba. As you know, Cordoba is the city worldwide with more places that are World Heritage areas. So they were very worried in order to find the balance between tourism and the citizens of Cordoba. So in this video, we have applied some trial points in order to have all the inventory of the different urban elements, and it allows us to identify the state of the art of green areas, the state of the vegetation, high vegetation, medium vegetation, low vegetation. So thanks to this kind of combination, you can launch algorithms in order to provide value to the city, to, in this case, related to green areas, water areas, how to improve the irrigation in specific areas. And the following video is related to a company that is a spin-off of the UPM, of these schools, that is DeepTech. DeepTech, that is led by Candela and other guys that were very close to you. They have a top-notch algorithms in order to analyze the satellite information and identify the health of building structure. So they have a specific algorithms and they analyze the movements of millimeters, horizontal movements and vertical movements, and they can identify what is happening related to the structural health of buildings. So we have used to analyze the buildings that are key for the downtown of Cordoba. I think it's a very, very interesting application of combining engineer with the ordered data provided by IT and OT domain. As you can see, the health of the buildings in Cordoba is very good. So it allows us to identify risks in this kind of infrastructure. So that's all from my side. I will provide you at a glance what is happening in the market. I think your knowledge and your attitude, because you have the knowledge related to ET engineering technologies and the other technologies, are very valuable for the companies. In our company, we have a multidisciplinary team, and we are combining the classical teams focused on BIM or even on GIS to provide this holistic view, because what makes the difference is how to handle all these emerging technologies in a common way. So thank you so much for giving the opportunity to share with you our vision in this talented room. So thank you so much. See you soon.
Starting this second session where we will be presenting the Capstone projects for us as the coordinator of the Capstone project. It's quite an honor to say that we have a great commitment from all companies. This is quite important because, as I said before, for us is the main key is not only to give you knowledge about digital twin, but also to connect them with the needs of the industry. In this point, I would like to emphasize that AGESA has been a great companion of this master since the very first beginning, as this is the second year that they are collaborating with us. Last year, the goals that they were able to achieve were great. It was an outstanding Capstone project where they were able to connect the structural management of a dam, and it was quite a good example of what might be achieved if digital twins were implemented in every field of the civil infrastructures. And for me, it's quite a pleasure to see that they are also quite happy with us because they are continuing with this second proposal of the Capstone project that is going to be dealing with the operational optimization of a road tunnel, that it is quite an interesting topic, and Carlos Rodriguez will be presenting in a few moments. Just for all of the presenters, as we are quite tight on the schedule, I would like to emphasize that it might be quite important to stick to the 10 minutes that are on agenda. So thanks a lot for that.
Okay. Thank you very much, Alejandro. I would like to thank the organization of the master for allowing us to be on this Capstone project this year again and lead the Capstone project of a road tunnel for operation optimization. I will be quite brief. We'll with an introduction, project description, digital twin solution for the channel, and the team that is composed for this Capstone project. AGESA is an international company offering integrated services covering IT services, engineering, and consulting. We have more than 12,000 employees around 14 different countries, and with local office in more than 20 countries. The AGESA team will be composed by me. I'm NC Industrial Engineering, specialized in digital twins and innovation in engineering, and by Fidel, he's the director of the design area of AGESA, who I would like to apologize on behalf of him because a last minute problem, he couldn't come. Our understanding of digital twin, we understand the digital twin as a virtual replica of a physical asset, process, or system that is fed with the maintenance, health, and operation information updated through the life cycle to implement technologies such as AI, big data, or virtual reality to generate value and improve the decision making. The technology enables of the digital twins, in our point of view, are IoT and data acquisition to get all the information of the physical assets, cybersecurity and virtualization to secure the information which was in the OT silos and now is in the IT layers, model and simulation and AI and big data to predict the behavior of the system, and extended reality as an user interface for the user of the digital twins. We will be developing the digital twin of the tunnel of Mediafanega. The tunnel of Mediafanega is a tunnel located in the north of Seville with a length of 800 meters and in the A66 highway. It's managed by the Ministry of Transport, Mobility and Urban Agenda. The aim of this project is to create a digital twin that models the tunnel, its installation and various sensors using AI models to predict the behavior and optimize their operation. AGESA, we have selected this tunnel because AGESA has participated in the design of the tunnel, in the technical assistance, in the construction phase, and is now in charge of the security of the tunnel. So we have a lot of experience regarding this tunnel, so it will be great to develop a digital twin as a next step of the tunnel. In addition, I would like to thank Emilio Asensio and Antonio Muruais, who belong to the Ministry of Transport as responsibility of the conservation of the tunnel and subdirector of innovation and sustainability of the ministry, because they have approved the work on the tunnel and are also very interested on the results and will be supporting us in the development of the digital twin. The tunnel control monitoring system is called CBAP, and it gathers information from different facilities around the tunnel. It gathers information from the traffic, such as the intensity of the traffic, the opacity, the speed, vehicle types, and distance between vehicles, the weather regarding humidity, temperature, wind speed, pressure, and solar radiation, variable signal and digital actuator on the tunnels, lighting with light sensor and lighting device, and the ventilation with gather information about the carbon, opacity, visibility, the oxides of nitrogen, wind speed inside the tunnel, and wind direction. Given all this information, we have thought of some models that we could develop for the digital twin. Our thought on this digital twin development, we start with a reality capture of the tunnel and a BIM modeling using this point cloud generated. Then to evaluate the data acquisition system to gather all the information gathered from the tunnel. With the information, we will develop a functional modeling using AI or physics-based models. And finally, we will integrate all the models generated, the BIM models, the data acquisition, and the modeling using a human-machine interface, a user interface, which we'll be developing uses web platforms to gather all the models that have been developed. We have made a preliminary model analysis from the models that we could develop. The ventilation efficiency control, maintaining optimal air quality while minimizing energy used by the fans. Lighting optimization, adjusting tunnel lighting based on traffic density, natural line, and a tunnel entrance, and the time of the day to conserve energy. Air pollution correlationship. We would like to correlate the traffic data inside the tunnel with the air quality to use the traffic downstream the highway to predict which air quality will be established in that tunnel and optimize the ventilation system to avoid that threshold of air quality. And another one is traffic flow prediction, forecasting traffic flow to prepare for the tunnel for peak usage. That's our preliminary model analysis, but we will be working on other models and we will finally decide which model we will develop. And the project team will be composed, as I told you, by me and Fidel as AGESA coordinators. We will have also the support of the AGESA team from software developer, data engineering, and infrastructure specialists. And from the university, I don't know yet the academic supervisor, but we will have some academic supervisors. And the student profile with Ana Rocío Racero, Hossam Farah, and Sembora Salik. So I think I stick to the 10 minutes. Thank you very much for the presentation. I hope you like the Capstone project that we will develop. That's all. Any questions about the project?
Okay.
So, thanks. Well, for the next Capstone project, I would like to emphasize that this is a keystone for us because we have achieved to come to our site with a Turkish company. Last year, it wasn't possible because at that time we had some administrative.
Hello, everyone. I'm Serhan Karahan from Sampaş.
Wait a moment, because I can hear you through the laptop speakers, but not in the room.
Okay.
Serhan, try to talk.
Can you hear me well?
Can you hear that? Okay, it works.
Okay.
Let's try again, please.
Can you see my screen as a full screen?
Yeah.
Okay, then I'm starting my presentation. First of all, thank you very much for this opportunity. We are very pleased as Sampaş to participate. And I will present you this topic about campus and building management via digital twins and BIM. So I will first want to start with the presentation of our company, Sampaş, and then talk about the problems faced and our solutions. So as Sampaş, our main fields of interest are firstly smart city applications. For example, smart water management, smart transportation. We can say applications that help city decision makers make better decisions based on big analytics. That's how we define smart city applications. We base these applications on our digital twin and WebGIS platforms, where we can process geospatial data. And we also have MIS applications that are spanning more than 40 municipalities. So we have so many citizen data, actually urban data. As Sampaş, we were founded around 44 years ago. And in this time frame, we have served more than 500 municipalities and more than 25 million citizens. And in this time, by cooperating with more than 50 national and international business partners, we have so many international awards like Smart City Expo, Eurocloud, and so on. So we would like to bring this experience to the project. So I just want to mention some of the problems that we face today about building and city management, because everything is getting complicated, technology is getting complicated. We face some inefficiency problems in operational life cycle. And also we have security vulnerabilities, environmental sustainability threats. Okay, sure. I will then, no problem. I will then do in the next round my presentation, I guess. No problem.
Mucho jaleo porque
Pero sí, o sea, por los fallos de la pantalla.
no, pero es que ahora el audio, como está presentando.
Ah, desde.
Complete proof that they.
Firstly,
The organizers and the directorate of this master to let me to be here with you this morning and to be part of this, I expect it very interesting project. Okay. So let's just some words about our company. Ineco is an engineering and consultancy public company that belongs to the Ministry of Transport in Spain. Our shareholders are the main operators of the Spanish railway and air navigation infrastructure like Adif, Alta Velocidad, Renfe and Enaire. We are all over the world with different projects in the 5 continents. Our main figures are more than 6,000 professionals and more than 300 technical disciplines, so a very broad variety of technical disciplines in different sectors and comprehending different solutions, presenting in the whole life cycle of the infrastructure, in general, transport infrastructure, but nowadays IT development as well, and different sectors, as you can see, and I'm not going to stop here a long time. So first of all, only one reflection about the concept. I would like to use this quote that I don't know who was the author of this. It was included in this position paper written by the Building Smart International in 2020, so it's not very recent, but it means that digital twin as a concept is a very broad concept that we have to go into detail and adjust with 3 very key aspects that our proposal for this Capstone project we will pass through. First of all, to find and visualize that, in my opinion, is a very challenging objective to find and visualize all the data that we can get or collect from our infrastructure. This project will be about a railway station, and it's one of the biggest railway station in Spain, in the south of Spain. So a lot of data, static data from the infrastructure that is already built and in operation to collect all this information, to put in the same place and to have the chance to visualize and to find, and it needs some structure, of course. And the second one, this first one is sometimes not called as a digital twin, but I think it's very important. But the second one, of course, to understand and analyze what we have collected previously, and the third one, going further to predict and simulate. And our proposal is to go through these 3 main aspects in this specific station, with a common outline, of course, in this case, based on BIM information. It must not be in this way in every use cases, but in this case, based on BIM digital information, capturing some information from sensors and SCADA systems, creating a data integration management platform in order to allow us simulation analysis and optimization, and using different kind of technologies. And with the some benefits expected. Of course, this is very ambitious. I'm very ambitious for this project. This will not be the objectives of the project, but our objectives are part of these benefits expected, and will be part of probably of further developments in this station. So going to the detail of the Capstone projects and overviewing some of our objectives, of course, to monitor the assets status in real time under a 3D dimensional representation using the BIM models of the station, to have the chance to analyze the data in real time, to extract information and facilitate decision making, and in fact to make some dashboards in order to improve energy efficiency, and to go to the third part, to the third key aspect about simulations on the virtual models, simulations, predictions, etc. So the main features is the integration of the BIM models that are currently developed. So we have those models, probably, as I will say after that, we have to prepare those models to acquire all the data, the real-time data, and to be able to visualize it through these models, because those models were developed with other purposes, but we have to adjust them. We are going to see some pictures of those models, as I say, integrate data from existing sensorization SCADA systems of the stations. This is a real station in the south part of Spain. It's Malaga Maria Zambrano station. It's not the biggest one, because some of them are currently involved in extensions works, like both in Madrid, Chamartín and Atocha, some in Barcelona or in Valencia. So it's better to have a stable station without many works ongoing, to work with the maintenance team of the station as well. And this is a very important thing, that the project will be carried out with the collaboration of ADIF, that is the owner of the station, that is the organization in charge of the maintenance of the station. They have provided the BIM models and will provide real-time data from sensor and SCADA system. Of course, as we can see, we are going to use these data sources, the BIM models that is already with us, and it needs some processes to get them the capability to acquire all the SCADA and IoT data, and to the chance to use other sources like weather forecasting, weather data from other suppliers, in general public suppliers, and data that is already available. So, and the previous one was related with this first key aspect, to find and visualize, and of course the outcome of dashboards in order to understand and analyze the second key aspect that I mentioned before, and to go to the third one, simulations and predictions, and hopefully using artificial intelligence on that. But in the team, we have to discuss, this is only the proposal, we have to discuss the final scope of the project to be enough ambitious. We want to be a little bit ambitious, but affordable, to make the project affordable for the team. And of course, those digital skills that are being acquired by the team, by the students in these masters, and related with digital models, programming and software development, and of course, data science and artificial intelligence. So real application of those skills. Just a very brief overview on the station. This is some pictures from the BIM models of the Malaga María Zambrano station. This is a huge station, and probably we are only going to use some parts or some systems of the stations. There are some pictures inside, different places, corridors, or main halls, because there is a commercial mall inside the station as well. So we have this, we already have this part of the data that we need as a container and integrator of all the data. And with a plan split it in 4 phases, the first 2 ones related with this key aspect, find and analyze, of course, prepare the BIM model for the connections with the digital twin platform, and the second phase about the integration of the real-time data. And the third and the fourth one related to the last 2 key aspects, obtain and creating dashboards for decision making, and the last one, hopefully, employ the artificial intelligence for simulation and prediction. And all of it made by a team, and only focus on the students' teams, but there will be a support from Ineco, of course. And I would like to usually to talk about this, what I call hybrid professional, technical professional that know the needs in their own profession, in their own activities, but with digital skills that allow to go farther and to connect technology, new technologies, digital technologies, of course, with technical activities. And our group, the 3 of them, are Mario Castro, that from TIPSA, and Morilla and Federico Giuliano, that is very well known here in this place. And that's all from my side. Thank you for your attention and patience.
Well, thanks a lot for your talk. The next presentation of the Capstone project, it's a clear example of the commitment with this, with the project from the sunset, not only from the point of view of the collaboration of the company, but also regarding the training of their workers. This is quite an example for us, because it is quite an effort from this company to bring us not only the students, but also the Capstone project where they want them to be part of. So for me, it is a pleasure to say that this is an achievement that has been possible thanks to our help of the people from Paris, from Points SSE. And we would like to also to present now the bridge monitoring of a component of rail digital twin, that it is that we will be presenting in this moment. Thank you.
Okay. So hi, everybody. Thank you for the invitation. We arrive in force to introduce you our Capstone project. It's a Capstone project from SNCF Réseau. It's a railway infrastructure management company. As you can imagine, we have lots of objectives in our company, but one of them is to understand the condition of our assets and to monitoring them. And this is for several reasons. The first one is to better monitoring our installation, our facilities, and to improve the utilization of our facilities. We need to assess the impact of our traffic flow by minimizing the impact and the monitoring of our risk of incident and risk of breakdown. We need to improve our asset management policies and to make more informed decisions, to lead better choice to the areas and to the operations. And we need to give meanings to our management and maintenance work and to our operators, to highlight data analysis and to enlighten to human interventions. These issues are very crucial for SNCF Réseau, and we must improve our performance to optimize maintenance cycles and to increasingly move towards predictive maintenance. To achieve these objectives, obviously, digital twin has an essential role to play. And in this capstone, in particular, you will discover the goal is to leverage sensors already in place on the field and to broaden the scope of their use to serving, monitoring, and to remote surveillance needs. So I'll let you start what.
This was about the context. We can't remove the slides. Okay.
Yes. So no, that's okay.
Thank you, Emilia.
That's your way. Okay.
Let's start by explaining why we do this project, because why is always very important, especially when we talk about a digital twin project. Like Emilia just explained. Monitoring the railway system is very important for us because the railway system is really complex. What you see every day, it's the train come and then take you from point A to B. But behind this, it's a very complex system, and it's a composition of a lot of small systems. So when we talk about the train, when the train starts from point A to B, he will encounter a lot of events. For example, when the train pass by the bridge, maybe a truck can hit the bridge, and that can cause a very serious problem. And when the train go nearby the forest, usually sometimes the wild animal can come out from the forest to take a walk. So if the wild animal hits the tree, it can be really very dangerous. And also when we go close by a cliff, some stones can falling down on the tracks. It will block the train, and sometimes it will just make the train to get out of the track. It's also very dangerous. And the same for the level crossing. Sometimes if the driver doesn't look well at the signaling, it can be the car can be stopped between the two blocks. So when we talk about this, maybe it's not very evident for you to visualize, but when we look at the numbers, the height of the truck, it can be onto 124 accidents each year, and the height of the truck represents 80% of the accident on the bridge. When we talk about wild animals, it can be 8,000 train impact each year. It represents 30 million of lost per year. And when we talk about time, it's about 4,000 hours of delay. In Normandy, it's a region in the north of the French. It represents one train hit by the wild animal each day. That means each day one train needs to be repaired. It's a lot. And also other element is also very serious. So if we follow the logic of the digital twin, we need to put IoT everywhere for the bridge, for the wild animal, especially when we don't know where it passes exactly. So we need a lot of IoT. And also for the falling stones, and also for the cars. And at the end, it will represent a lot of money because it's about the linear infrastructure. We just took one portion, 40 kilometers, but in French, we have more than 20,000 kilometers of railway. So imagine the cost behind of this. So that's why we need to come out with a more affordable solution to do our digital twin program. I will let Pierre you to find the solution.
Hey, thank you. What a challenge.
You have 10 seconds. 10-second solution.
Huh?
You have 10 seconds.
Yeah, 10 seconds. Yeah, thank you. 10 seconds for a solution. Thank you. Here it is. Here it is. Optic fiber. Normally, an optic fiber works like this. You send a light in it, and sometimes there is dust inside the optic fiber, so that some part of the light you send is reflected and goes back to the origin. But if you have vibrations on it, the light that is reverted contains the signature of the vibration. That's an opportunity for us to know what happens on the track with a single wire. For example, if we can follow the train because the train makes a vibration on the ground, we can see very easily if a stone is falling. Make the stone fall, please. Thank you. And then it is recorded in the optic fiber. Okay. For example, here is a train that is passing, and it's recorded through the optical fiber. Here it is. So it's very easy to follow them directly from the ground without a lot of IoTs. Okay. And this is an operator walking along the track. This is a train passing here and here. And this is a train, an operator who is just walking, and just the steps he makes just near the optical fiber can be registered. This is a zoom of the signal, and this is each step he makes. Okay, it can be recorded thanks to this. The other advantage is we can very easily know what kind of material is used, because the signature of each one is different. Okay, next. Here is a map of France and all the tracks in France, and in black you will see all the lines that are equipped with this. Okay, sweet. And one of the use case is this. Can be dangerous because if a truck just moves from 1 or 2 centimeters the bridge, this can be very dangerous for circulation. And you can imagine that we registered 174 accidents last year, but all of them are not recorded by the police. So we don't know exactly how many of events happened. That's why we're very aware about this problem.
Thank you. Now I will use this one. So now we see why we are doing this, how we are doing this, and now we will see what is the solution that we imagine to set up. There you can see some steps that we imagine when we collect the fiber signal from the sources, which we will put on 40 kilometers. We will do some treatment on the data to make it understandable by people. As you can see here, the signal, it's just not useful for the normal people, the operator that are on site. So we will make some treatment to make it useful for them. And the objective is to send an alert when we get a bridge which is hit by animals or by vehicles, for example. But sending this alert, it's not enough for operators who are on the site. That's why we'll combine the alert with some new information about the bridge, for example. You can see here the functional description of the bridge, the state of all of the assets that compose the bridge. And at the end, the operator will have all the information that he needs to make, maybe to try to solve the problem and make a solution based on these informations. Why I have this, I don't know. Yeah. So we imagine that we learn from our courses that we have a lot of IoT. To have a digital twin, we should have a data in real time that are updating our databases automatically. So we imagine that we have optical fiber, which you can see just there. And then the optical fiber is like we cut it in different perimeters, and we will only monitor the perimeter where we have the bridges, because our use case is about bridges. So we will only monitor the bridges, and we can imagine that we have an IoT for bridge 1, for example, #1, and IoT for animals, but we are not trying to solve the problem with animals, and another IoT for the bridge 2. What we will get at the end is a vibration signal that we will process at the end. So now I will just go to the planning of the project. We imagine that we will start today, the project. We already start to design what are the contributions of every member of the team that we will see just the next slides. And then the second phase will be a 3D modeling of a railway. Maybe we'll use ArcGIS to put it in the real place, and some technical architecture. The third step will be structuring and cleaning the data. As you saw, we have some raw data that are not usable. And at the end, the aim is to make a digital twin. So we'll use some data visualization based on the need of operators. And we will try really to simulate an accident. If we get it a real one, we will use it. But if there is no accident, we will try to simulate it and to see how the operators will manage it at the end. So about the team member, we have our industrial supervisor, which are Emilia Frigier, just next to me, Flavien Viguier, who couldn't be with us today. And we have an academic supervisor from University of Technology of Troyes in France, which is Guillaume Ducellier. And a student, we are Pierre-Yves Lepage, Yuliao, and Gabor, which is just there. Sorry, Gabor, we are putting our SNCF hats today. That's why we are presenting. And me.
Thank you. So as you can see, this project is very important for us. It's a real need. We need to manage and to monitor our 30,000 kilometers of network. And this kind of sensor could be a really important response to manage and to optimize our maintenance predictive. It's a cheap solution because we have this sensor in the field, and this optical fiber is already on site. and it's already maintained, it's already monitored by teams. We can imagine as a resilient solution and very robust one. And we saw like one of use case, but we have lots of opportunity with this optical fiber. And one thing is very important for us. It's not just only manage and monitor like alert or problem on the field, but it's send alert to the maintenance operators and to organize or optimize maintenance. And this is all the processes which could be imagined and worked in this capstone. So thank you and if you have some questions, we can talk about it after maybe.
Thank you very much.
Okay, thanks again for your presentation. Next, we will be trying to again with SAMPAS. Let's hope that we have been able to solve all the issues that we have previously. And if not, we will require to continue with the next talk. So I don't know if we might have some help from the IT guys.
Hello, everyone. Can you hear me well? Can you hear me?
As low as possible, and we will try to avoid that echo that we have.
So I assume you hear me well. I heard that. Right. Okay, I'm starting my presentation then. So I'm happy to present this campus and building management presentation to you. We utilize in this context digital twins and BIM. I'm Serhan Karahan. I'm working for SAMPAS and I'm responsible for smart city application projects. And, digital twin So here we have
Of the two companies that are proposing the Capstone, and then I'll give a little bit of framework on why do we think this is an interesting Capstone project. And then I will pass on to Attila, so she will give the specifics of the work. So this Capstone project is an initiative that we are proposing, ARUP, in collaboration with the BSC, which is the Barcelona Supercomputing Center. So a little bit of introduction. ARUP is a global company. We are around 18,000 members across the globe. We work in all continents, and we are basically designers, engineers, and consultants on the built environment. This means that we work infrastructure, that we work cities, and we work building scale. Proposing this, the Barcelona Computing Center colleagues are not here today because they are based on Barcelona, but they will come when it is necessary. But I am here on behalf of them to present them. The BSC is one of the high performance computing centers of Europe, where there are only 3 of them. And they are a research center, and they have one team, which is the data and visualization team, who is the team who's going to work with us on this project. Why do we want to propose this? The Barcelona Supercomputing Center is now working in developing the VCT, which is one of the urban digital twins, which we think will set the ground for the future of the digital twins, at least in Spain, because it was born with 2 main aspects. One, that it is with a human-centric approach. And the second interesting aspect is that it is meant to be scalable and replicable in all cities. So we think it's going to really have a future and a sustained next steps. We are working with the Barcelona Supercomputing Center now in this specific project, and in another 2 projects, both of them related to urban digital twins. And we share many interests in common. Like we are working together in the Reallocate project, which is a H2020 project dedicated to understand how to improve cities. And I don't want to extend myself too much because I think we need to go into the specifics of the project. But it's just to say that this shared interest in making cities more livable, making cities more citizen-centric, it's one of the shared interests between the 2 companies. And we hope that the project that we are proposing is in line with this idea, and that will bring new ideas. Thank you very much.
So let's jump into the specifics of the project. Christina, thank you for the context. We are proposing for this capstone a data twin of what is called the Safe Routes to School, to develop an assessment and an evaluation digital twin of this. The Safe Routes to School are public programs, so this is the first item that we need to understand. So the data twin should support decision making as a public policy. that allow children and adolescents to travel to school in a safe, healthy, autonomous, and sustainable manner. So this involves understanding the domains as mobility, air quality or climate, for instance, whether by walking or cycling. So again, it refers back to what Christina was describing as BCD, which is human-centric and behavioral approach in order to support policymaking. So for this project, I think the slide cannot be seen. Okay, so for this project, the data that we'll be using are both real-time data and historical data on urban morphology, topography, microclimate, air quality, mobility and accessibility, road safety and perceived safety based on feedback from students and parents. And the final scope of the project will be finalized with the students, because this data twin could involve, is not required to develop the whole digital twin, but it could instead focus on specific assets, on analytics, on image processing, or simulation models of visualization. So let's jump. So just to give you a bit more context to the problem or to the theme, why are we proposing a digital twin of the safe routes to school? The increase of the use of the private car in cities has created and heightened the traffic congestions and creates unsafe conditions for children when traveling around schools. And at the same time is worsening the air conditions, air quality conditions, and reinforcing some unhealthy mobility habits. Since 1989, which was the first safe route to school launched in Bolzano in Italy, since then there's a growth number of projects in Europe. Currently, there are 1,200 projects that that have been already given, that have already some impact. So, for instance, in the case of Barcelona, it was implemented in 1999, and since then, the numbers show that it has been a decrease of 40% of collisions and a 43% of reduction in pedestrian injuries. So we think this is an important policy, and we want to support that. So in terms of the Capstone project, we have identified 4 specific objectives. So the first one is identifying the key parameters that define how a safe route to school looks like, let's say. So this will involve literature review to understand the urban morphology aspects. So, for instance, the width of the streets, the cross-section of the streets, the intersections, etc. Microclimates, so to understand the comfort. So we could also make some comfort analysis. Air quality, road safety to assess the mobility across the cities and the specific routes, and the perceived safety in terms of lighting and other parameters. Secondly, gather and process data on these parameters to assess the cities under study. We will be assessing, we have a list of 12 cities that we are already participating with in the Reallocate project. So the part of the Reallocate project is already focused on developing these kind of projects. So we will start by gathering data on these aspects that we already mentioned, in order to develop a standardized methodology that can be replicated to all the cities. Thirdly, develop a routing algorithm that accounts for what in GIS is commonly known as impedances, so the obstacles that are in the different routes, and also the routing conditions. So for instance, if you want to get to somewhere quicker or by a shorter distance, or with less slope, for instance. So we will be working with the students on defining these algorithms. And finally, the idea is not only to assess the current safe routes to school, but also to simulate new routes to school that are more suitable for different areas in the city to go to a specific, what is normally called like the point of interest, so the school in this case, to also provide insights and data for the policymakers of the different cities. So we have propose a preliminary methodology that we will be well tailoring today with the students in the afternoon. So within these 4 objectives, we have these different steps. So we started with the literature review, the city selection. So we have Barcelona, Lyon, Gothenburg, Bologna, Budapest, etc. So by doing this literature review, we will be identifying the key parameters that define a good route to school, as we already mentioned. Then the next step is scoring and weighting which of these parameters are relevant to the specific cities. So for instance, in Spain, for instance, in Madrid, climate will be an important parameter, specifically in warmer months, whilst in other cities with other topographies and in other climate conditions and other urban morphologies, other parameters such as the roads, the width of the roads, etc., may be more important as well. So from there, we will start collecting data, and this is something that also we will work with the students to define the data that we will be collecting, since we wanted to make this an open source project. So we wanted to use always open data. So to ensure that the methodology that we will be proposing can be easily replicable to other cities. So for that, we propose different techniques to extract this data. It's not only to download the data from open portals, but also to process images, for instance, from Google Earth or from different sources. So to extract urban morphology parameters, for instance, also to connect to sensor data that some cities may have available, census and socio-demographic data to understand where children are actually living, 3D models that are available in many cities or that could also be developed, and of course, traffic data that can be extracted from open sources and also closed sources that we also have access to thanks to the Barcelona Supercomputing Center. So we will define this methodology, and we will have a first assessment of the cities that we were studying. And then the next step will be defining these parameters, those important parameters, in order to start defining these routines. So probably this routing algorithm may be ending in a kind of an application, of an application that you could define your parameters, the key parameters for your routines. So your point A to point B, and put in some impedances, or let's say I want to go to this point, intermediate point first, then go to another, or this time this road is closed, etc. So we will be working with the students on that. Of course, the sophistication of the algorithm can be super high. Of course, I mean, Google Maps is a good example of that. But we will define that later with them. And then the final step is using this algorithm just to identify new routes that can be interesting for and safe for the children. So finally, this is the team. We have our students. I think Danny is remote, but here we already have met Nikolai and Negar. From the company, from Arup, Christina and I will be supervising the students and helping on this process. And from the Barcelona Supercomputing Center, Patricio Reyes, who's the head of the urban data science and senior researcher, will be helping us with that. Also, he has mentioned that other people from the team will be helping. He has data scientists and other people from different domains that will also be supporting the students on this. Of course, also from Arup, we have different experts on mobility, on accessibility, built environment, etc., that will also be supporting if we have specific questions. And from the university, Juan Benavente from Transit will be also supporting us. So that's it from our side. Thank you very much. And if there are any questions, we're happy to answer any. Thank you.
Okay, so we'll be updating the agenda
today and tomorrow because we are clearly out of a schedule. So my talk regarding the administration of the Capstone project will be carried out tomorrow morning instead of today. So we don't have to rush in the presentation of the rest of the Capstone project. That will be a bit unfair for the company that have come here today. So with that changes, that will give us the new time for introducing Atlantis. I'm really glad to say that this is a newcomer to our project, that it's also approved to see that we have some attraction of new companies and with some new interest. So the floor is yours. Thank you very much.
Thank you very much, Alejandro. Good morning, everybody. Very happy and honored to be there, to be part of this very interesting project of digital twin and with the Capstone. So I will introduce the proposal we made. Just let me check how to go to the next slide, which, no, not that one, just, okay. So the plan is the same, I think, as everybody. So just to introduce, we are on a motorway project, an infrastructure, which is in the southwest part of France, with two companies which are involved. Atland, which is a small concessionaire company in France, independent. I say small because we are not part of the main groups like Vinci or Sanef, with the shareholders you see on the screen. And we are working in a scheme where we have the concessionaire company and the operating and maintenance company, which is headed by Sandrine Krief, who is here with us today. And overall, we are a bit more than 100 people, 7 in the concessionaire company and 100 on the motorway itself. So we are in the southwest part of France, not so many kilometers, just 104, but strategic link between all the Iberic Peninsula, Portugal, Spain, also the north of Africa, linking all Europe in the north and east of Europe. So the main stake for us is the truck traffic, linking these countries with a high level, about 10,000 trucks per day, and operations which are quite recent because the concession, which was an upgrading of an existing road, started in 2011 and start of tolling operation in April 2013 with 2 main toll gates on the motorway. So we are using several tools. You see on the right, on the left, sorry, the traffic tree, which is a picture which I quite like, done with traffic modeling, but which simply shows where do the truck comes from and where do they go, which shows that we are really at the heart of the European commercial traffic. It's a 2x3 motorways, quite easy in a way because it's quite flat and straight, but still upgrading of an existing road, which can dates back to very ancient times because we are on top of a Roman old link, and also during the Napoleon era, the pavement started. So it's a progressive and gradual pavement. So one of the main questions is what is inside somehow, and also the way we are going to run and to maintain this pavement is very important. So as you know, on such a linear infrastructure as a motorway, and especially when it's an upgrade of an existing road, a fine modeling appears quite necessary because it's not obvious to know exactly what is below. We have the design, but the design was only on the upper layers. Proper maintenance and operation is also key to optimize the functionality, to avoid failures and major accidents. Also for us as road operators, the safety of our workers is on the top of our priority, which needs good training, but also a good knowledge of the road assets itself, and also good information processes, both for drivers and operations. And of course, this knowledge is also the ability to keep track of changes and developments. And that's where all the digital tools will come in quite obviously. So our strength is first the team, which is highly motivated. We have quite a lot of data, even if, well, it's a bit of a patchwork. On the other hand, of course, all the softwares that you might know or use are not fully mastered. So we have licenses, but not the knowledge on all of them. We think also that existing standards are not so well reflected in our databases with an S, because we have several, which is fact is also an opportunity, we think, and that was also in the discussion early with Mathieu and also inside of our group, is that we think that especially regarding roads and road pavement, the standards are not fully achieved yet. And so there is a very big interest in this work to help also the community to have a more standardized approach on pavement. Also, we will face a new pavement renewal in some years, well, not tomorrow, but in a few years. So that's a good time to process that. There are also already some open exchange formats. So that's a good point. Of course, the threats are also that, well, there's this huge tools diversity and heterogeneity. Presumably, the ability of really have open exchange format is not fully open, so especially for pavement-related topics. And also, the compatibility of platforms and tools with these open exchanges formats are not fully, well, we are not fully assured of that. So today, it's quite interesting, and the capstone is quite open. That's what we were saying also with the students, because we have several tools. We have just renewed our traffic management system in 2023. You see the new video also, which are very accurate. We are also renewing the asset management system, which will be developed by Aegis under an ArcGIS framework. And also, we have already done some LiDAR analysis with CloudPoint, and we are defining 3D models in various also aims. Because on one hand, we are also part of an automated vehicle project, a European project, automotive SICAM, with the University Gustave Eiffel. But also we have developed some 3D models for some time and are testing some tools linked also with traffic modeling. So basically, the first target use case is pavement, as you have mentioned, for which you see the patchwork, because the pavement has been renewed. Each lane is different, has a different history. Today, well, we have approximately a good understanding, we think, but which is mainly a text merging, as you see on the picture on the upper right. Of course, probably most of you know the organization of pavement layers. But yeah, that's what is interesting. And we think also, after having discussion, that to enable us to have really an optimization of the next pavement renewal, we would really like to have a full 3D modeling of this pavement and especially the underlayers. Of course, we will have other use case like noise protection plans, but more than protection plans, you know that the European framework now have all these noise protection plans, which are published every 5 years. Of course, road safety and especially roadwork simulation are also very important for our workers. So the ideas which are behind are that, well, we need an inventory and appropriation of available data. So we will propose some bibliographical research, literature review, but also methodological one. As I mentioned, the standardization in terms of roads and pavement for digital twin and BIM is not fully achieved. The development first of a geometric and information model that will feed the digital twin, and then implementation. We understand well, and that's also what we are very interested in, is that the digital twin is not only 3D, it's far more than that, and it's really making work together several entities and several softwares to ease our operations with a main user interface, which will be user-friendly, of course. And this integration of data and models will be of very important help for us. What is also interesting, and that was our way of promoting the capstone, and we are very happy to see that it has been selected, is that obviously this work is transferable. Road assets is one of the most important and worldwide. Every country has roads of various qualities, but it's a very important asset. Pavement has a very important role on that. And also in terms of finance, roads are operated by concessionaire company, some of them. And we are happy also to have a student who is Maria Eugenia, also in a concessionaire company. And of course, pavement renewal is one of the major parts of the works and has to be financed. So a good knowledge will help that, of course. So we will work to improve the decision-making process through simulation, predictive maintenance and optimization, and real-time data analysis and visualization are keys, but those are quite general. In a short while, the idea is to start by the information modeling, try to focus on the pavements, and then to have the digital twin to be used for the pavement renewal. Well, that's the picture focusing on pavements. But as I was mentioning, we have many other ideas, and we will work together with the students to decide what we will really focus on. So the first step, as I was mentioning, will be data analysis, also BIM standards and format discussions to get a bit more knowledge on that. Early next year, we would like to have the first step into the information model, probably testing also what University Gustave Eiffel has done on the Civic. So Civic is the platform done by the University Gustave Eiffel for the 3D modeling for automated driving. And then in June, have the first pavement 3D model for also starting the twin type platforms, and starting end of the year to implement the developed model in a selection of platforms. Well, we launched a number, but we will see. And the two first would be pavement renewal, but also work site simulation, which is very important for our staff. And then in the end, trying to use fully the digital platform. And then we are happy, very happy with the team. So we have with us today Sandrine and Solène, who are in the back. So from Aegis, Exploitation Aquitaine and Aegis. We will be helped on site with Thomas Bergerot, who is the Quality Safety Environment Manager in the operating and maintenance company. And also Nicolas Ferrara, who is the head of the BIM Digital Twin Expert Department in Aegis. The academic supervisor will be Dominique Gruyet from University Gustave Eiffel, as I was mentioning, who is deeply involved in digital twin and 3D modeling. And we are very happy with our three students, Maria Eugenia, William, and Valentin, whose CV impressed us a lot, and we are sure we are going to do great works. And we have started investigating on references. We think there are good material. And that's it. Thanks again a lot for.
Well, then we have the last two presentations with this one. I gotta tell you that I have mixed feelings. I'm quite happy to see that NOMMON is again with us. They have been a great partner from the very first beginning. Javier, he is a former student of our school. I have met him quite a long time ago. We have get along quite well, not only from the student and professor point of view, but also as mates, as workmates. But the bad point about that is that he's gonna be searching new horizons in the really near future. So I'm a bit sad about that. But the good point of this is that another former student of our school is substituting him. So I'm quite also happy for Pablo, and I know we will be a great team on that. I will also want to thank him and the people from NOMMON from their support from the very first beginning. They had at some point much more experience than we did, and they really helped us. So thanks a lot for everything. Javier, I hope that everything is great in your future, and we will be here for you in case we meet again. Thank you.
Thank you very much, Alex, for your words. It's always a pleasure to be here. Today we will. I would like to introduce you to the Capstone project we will be supervising at NOMMON. Okay, it's the second year we do this. We were very happy with the experience we had the last year. So I hope that this year will be as at least as interesting as the last one, right? In my presentation, I would like to start by explaining a bit about what we do at NOMMON, okay, so that you can know the company more in detail, and then I will of course cover what is going to be the Capstone about. Regarding who is NOMMON, NOMMON is a technology company based here in Madrid that focuses on the exploitation of geolocation data for developing tools that help different sectors to take into account the activity and mobility patterns of the population when making decisions. We work for different sectors, for transport, for tourism, etc. And the core capability of the company is this exploitation of big data sources to understand this activity and mobility patterns. Actually, we do many things with this geolocation data. Okay, NOMMON has a quite extensive product suite that focuses mainly on two things: either to understand how people move, resorting to different data sources to help cities, transport authorities, these kind of stakeholders to understand how citizens move, their mobility needs. And also another set of tools that go more into the predictive side. So not only to understand how people move, but to anticipate how people will move and what different stakeholders can do about it, right? Last year, actually, the project we developed was more focused on this predictive side with one of our solutions, with WiseRide, for improving the operation of training systems. And this year, we will focus rather on the left side because we will develop new functionalities for these products that focus on how people move or how people perform their activities or how they use public spaces. And this is what the Capstone is going to be about. What is the motivation of our proposal? Well, first of all, I think we have seen already today that more and more cities are developing urban digital twins to improve the way they manage not only mobility, but more in general urban services. Actually, the city of Madrid is a very good example, and they are doing a lot of steps forwards on the implementation of their own digital twin. What these cities are facing also is that these urban digital twins require a vast amount of data on how people is actually using the city and how people is actually doing their activities in different public spaces and areas of the city. So these urban digital twins require accurate and up-to-date information on this. The objective of the Capstone project actually will be to develop a component of what will be an urban digital twin that will focus on estimating the number of people present in each public space. And this will be done combining different sources of dynamic and static data. Why this is an interesting thing to address by the Capstone project? There are many data sources out there that we could use to address this objective, right? However, it is quite challenging to develop a cost-effective and reliable pipeline to combine all of them and exploit the advantages of all of them to come up with a cost-effective solution for estimating this number of people present in each area. Here you have in the slide the two main dynamic data sources we will involve in the project. One of them is mobile network data. The other one is GPS data from mobile apps. Mobile network data is the data that telecom providers collect, mobile network operators, and refers to the interactions between our mobile devices and antennas of their network. So having access to this data, we have access to a sequence of registers that the users, the users of the mobile devices of a given telco operator live across the territory while using their mobile phones. The second data source that is interesting for this is GPS data from mobile apps. This is data collected by mobile app providers, any mobile app collecting location data. And normally we will have access to this data through aggregators. So there are companies out there that aggregate data from 10, 20, 30 mobile apps and resell the location points of all these apps. It is interesting to delve into what are the advantages and disadvantages or the limitations and the applications of these data sources. Mobile network data is very interesting because it provides us with a very large and good quality sample of population. For instance, here in Spain, NOMMON has an agreement with Orange Spain, so we will, for the Capstone and for any project in NOMMON, we have access to the anonymized database from Orange Spain. This implies that we have access to registers from up to 25% of the Spanish population. And it's also very interesting because this enables a continuous monitoring because we have the same anonymous identifier for many days. On the other hand, the spatial resolution of this database is limited depending on the density of antennas. Basically, the more antennas we have in an area, the more resolution we have because we know the location at the antenna level. In the case of a city such as in Madrid, where the Capstone will be focused, by the way, this implies a resolution of 200, 300 meters. So perhaps for some applications, maybe not enough. And it's also a data source that is not processed in real time. Normally, for instance, with the case of Orange Spain, we have access to the data at the end of the day, and these are very large databases. This requires some hours of computing, so it's not a real-time database. What are the advantages of GPS data? That is a GPS location, so we basically know the coordinates where the mobile device is, and most of these aggregators of this data provide a real-time service. So you can have access actually to the real-time GPS locations. However, they are usually very small samples, only perhaps 1% of the population. And when you explore the data, you can see a lot of discontinuity. So you may have a lot of registers from a single mobile device only for 2 hours of the day and no registers at all in the rest of it. So we at NOMMON we have been developing over the course of these years many strategies to blend these data sources. Actually, I have bring here you an example that will be actually the starting point of the Capstone that we are already applying in many projects. we can have a very robust estimate of the number of people present in the vicinity of an antenna with mobile network data. And if we want to know which proportion of these people is present in a very specific part of the coverage area of the antenna, for instance, a park, we can superpose the point cloud of the coming from GPS data and estimate probabilities with that. This is a promising method that actually we developed together with the communications faculty here from UPM. However, though it is valid for cross-sectional studies, analyzing only some days, it is very hard to scale in terms of computation and in terms of costs, because it will require us to buy both mobile network data and GPS data from the whole year. So something we want to explore with our students team in this Capstone project is how we can develop alternative methods that help us get a cost-effective and still reliable solution for estimating this type of dynamic population mapping. And this is where we can resort to spatial AI techniques, because if we find strong relationships between what we see in the dynamic data and static data sources that are free and open source, such as land use, cadastral data, the calendar itself of the year, etc., we can develop a method that only use an optimal set of days from these dynamic data sources that are very interesting, but also very expensive, right? How we will conduct the project? We will start with the definition of the specific objectives of the project and some research question to address. We will see also in this first phase which data sources can we have available, both in terms of mobile network data, of mobile GPS data from mobile apps, and land use data and other static data sources. We will help the students develop a project plan, the most closer to a reality of a current development in a company like NOMMON. We will, of course, help them and assist them with the data collection and the exploration of the data, so which metrics they should take from this data before starting the development. And then the development will start, right? So we will assist them in choosing the right AI techniques, in evaluating different alternatives to make this data fusion happen. And we will try to validate this by different strategies we have been using already in the last years, right? Comparing with other data sources, etc. Depending also on the time and the different skills of the students we will be gathering, we will also see how to visualize this through visual interfaces that can help understand potential users of this data fusion component, the benefits of this. I have forgot to include a slide from the team, but the team from NOMMON will be led by Pablo and Oliva, who are also here with me today. We will have Natalia from the UPM as academic supervisor that we already collaborated last year. And we are very happy to have three students. We will have Ashraf, Elena, and Alison. So it will be a pleasure to exchange afterwards with you your own ideas on how this project can be executed in a successful manner. From our point of view, what will the students learn? Overall, we want them to reflect upon how big data and AI can be integrated in urban digital twins. And I think this is a very good example of how the processing of different data sources, of different big data sources, can help us with this dynamic population mapping task. But also, because I think that it's important to remember that we are in a executive master. I think it's very important for you, and it will be very valuable if you can learn about 3 specific aspects. First of all, how to balance the cost and the accuracy of a digital twin, because the more accuracy we want, the more costly it will be. So it's very important to understand the requirements of the final users of the digital twin in terms of accuracy, in order not to waste money, so to say. And I think I'm sure that this will be part of the focus of the project. Also, something that is always very, very difficult to find the right balance and very challenging for those developing digital twins is the balance between personalization or customization and scalability, right? For instance, if we are developing, we will be probably developing the case study in Madrid. It will be very important throughout the process to make sure that every decision on the design and on the development of the methodology can be replicable in other cities, because otherwise we will be doing a work that is only useful for Madrid. And finally, the planning side of it, right? How to plan the development of a digital twin model. Which aspects do you need to take into account? The resources, the team organization, the costs related to those resources, etc. So besides the technical aspects, it's something we already did last year, and I think it's very interesting. We will also focus on how to manage this type of projects in a company. And that's all from my side. If you have any questions, you can come to us during the rest of the day. Thank you.
So, as it's usually said, last but not least, we will like to welcome our collaborators from Hungary. Attila will be presenting in collaboration with the company supervisor, one of the last Capstone project that we will be presenting today. As I previously said regarding SAMPAS, we are quite happy to welcome a Hungarian company to the Capstone project, and we are sure that it will be a successful. Well, we will be quite successful. Thank you. Yeah. Thank you.
Yes, welcome all, and especially our students, Jordan, Alenka, and Alex. We will be presenting on this Capstone project hosted by CEH and the Budapest University of Technology and Economics. The subject of this Capstone project will be an ongoing project, bridge, which is under construction in Budapest, in the heart of Budapest. It was designed by CEH, by our company. I was the project manager for this design job. And as for the project supervision, my colleague Attila will take the academic supervisor role on this project. Myself and my colleague from CEH, Adam, we will take the industrial supervision. Some words of CEH, you might not heard of our company. We are a mid-sized company based in Budapest, with around 300 engineers. We have 3 branches: bridge, building, and project management. Myself, I represent the bridge department, and we cover the whole field of bridge design. As you can see on the picture, we put a high emphasis on the quality and the hands-on approaches. And of course, along with the bridge design, we do also independent checking, bridge inspection, and other consultancy works, and also focusing on our domestic and international network, which is very important for us. Just a couple of our references in snapshots from recent years. We have been involved in several Danube bridges in Hungary. The bottom left right corner is it's a newly handed over bridge in the central Hungary. It's an extra dose bridge. As you can see, we have other type of bridges, cable stayed bridges, extra dose bridges, and we are very keen on development and using and applying state-of-the-art technologies as 3D modeling, lighting design, and other applications. As for the railway bridge, which is the subject of this project, you can see a picture of this of Budapest. This is south of the Pest side. You can see our bridges in subject. Yes, I'll just move back. In here, these bridges are part of a large railway development scheme ongoing right now in Budapest. And these bridges are under construction, as I mentioned. These might not be the largest ones in this railway line. However, the very important role they play. Here you can see highlighted the G1. We call it the G1 railway bridge within this cluster. This will be the subject of this project. Just in a nutshell, it has a span of 54 meters. It's a regular and nothing particular bridge, but it would be a perfect specimen for this project, we believe. As for design tools, we used Tekla. We developed this Tekla model up until to the construction level. Unfortunately, the workshop model was not prepared by us. It was prepared by the contractor, but anyways, yes, and I would pass over to Attila.
Okay, so again, we welcome all of you and thank you for the possibility that maybe I stand here. Thank you for the possibility that we can work together. I'm from the BME, the Budapest University of Technology and Economics. Maybe you will come to Budapest to us as well, and we are part of the education part as well. And I don't want to talk too much because we are in the lunchtime already. But as you realize, we are structural engineers, bridge engineers, and we try to focus on the structural digital twins. So we try to understand how this real-time IoT and sensor information and the real-time explicit dynamic analysis, which makes us possible to follow the behavior of the bridges. So how can we extend this to a full real-time structural digital twin? Because we want to calculate the lifetime of the bridge, maybe for special effects as well, and how the different loads which are going through the bridge affects this lifetime. So we try to implement these sensor information into a finite element software and connect it to the BIM model of the bridge, which we already have. And at the university, we have our own application for Tekla structures, which helps integrate this kind of data. But of course, it needs improvement. What we have an example, it's a road bridge. So we try to extend this application for a railway bridge as well. So we have a plan what these phases will help the guys and girls through the project scope. We have a separated part for finite element modeling with an advanced methodology through a dynamic analysis. We also want to develop a deep learning algorithm. We already use one for a road bridge, but it should be different for each bridges. So we have to teach this kind of algorithm based on the data we have and the structural behavior of the bridge we have. And also we want to extend this kind of application we have for Tekla structures to be able to show the digital twin data for the whole lifetime of the bridge, because our goal to collect all the data we have. Of course, this bridge won't be built until the next year, but we have the scenario, how can we do a virtual environment for that? So we will work on both sides. So it's a virtual digital twin, what we can finish in this project. So again, thank you for the possibility. And of course, later during the day, we can have the discussion and enjoy the lunch. Thank you.
So thank you all the presenters for your time and the collaboration of the companies that are part of the Capstone project. Just a quick reminder, take into account that the session that will be dealing with the administration of the Capstone project from my point of view as a coordinator has been shifted to tomorrow due to the schedule, because otherwise we will be really late today. So all your questions regarding marks, deadlines and all that stuff, I will be telling you tomorrow. Thanks a lot for your collaboration, and let's go to have, or Matthias is going to
just before going to Government, I know like you are all hungry, you know, but we are taking advantage of the presence of everyone to take a picture in the hallway here, just on the path to go here. That's a price to have lunch.
Sí, ya lo sabíamos.